Okay, I'm going to go over one of the problems that some of you had to go at in the thing I posted onto the classroom. It was a white rose fractions problem. And just to demonstrate how we go about dealing with these wordy sorts of things. And this one's also got some mixed numbers, and you might need to change mixed numbers into improper fractions, all that sort of thing. So it's quite a lot going on in this problem. So let's read it to start with. So a barrel holds 12¼ litres of water. A bucket can hold 3 11/12 of a litre of water. Max fills up the bucket from the barrel. How much water is left in the barrel? Okay, so you'll see I've already noticed that they should have had litres on there, and there's a question mark on there. Okay, what are the important things here? So we know that we are going to need to know how much was in the barrel to start with. 12¼ litres. We know that in the bucket, a bucket can hold 3 11/12 of a litre of water. So what's the question asking us? Max fills up the bucket from the barrel. So he's taking a bucket full of water out of the barrel. And then it's asking us how much is left in the barrel. So he's taking a bucket load out of the barrel. So the barrel starts off with 12¼ Max is taking a bucket full, which is 3 11/12 of a litre, out, and how much water is left in the barrel. So I think we're talking about a takeaway sum, starting with the barrel load, taking some out. So the barrel load is 12 1/4. And I'm going to remember it's litres. I'm going to put that up at the top. Litres. And then I'm taking out a bucket full. And a bucket full is 3 11/12. So that's the calculation I'm wanting to do. 12 1/4 take away 3 11/12. Now, that's not easy to do straight like that. Why not? Okay, hopefully some of you are saying denominators there, because whenever we're adding or taking away fractions, we know that we need to have the same denominator. So the first number has got quarters, or 4 as the denominator, and the second number has got 12. So we need to make sure they've both got the same denominator. And in this instance, I think what we need to do is to choose 12ths, because we know that 12 is in the 4 times table. So 4 is a factor of 12. And so I think that's what we're going to go for. So what I'm going to do, I'm going to say, we'll stick with our mixed numbers at the moment. So 12, and I'm wanting to do something 12ths. So over here, 1/4, what I had, is how many 12ths? So looking at the denominators, I know I've had to multiply by 3 to get from quarters to 12ths. So I need to do the same to the top to make sure I've got an equivalent fraction. So I'm going to multiply by 3, so 3/12. Okay, so 12 3/12 take away 3 11/12. Okay, so that's a good start. Have I still got a problem? Well, sometimes when you're doing these sorts of mixed number subtractions, you can say, I'm going to do the units, so 12 take away 3 would be 9, that would be fine. Then I'm wanting to do 3/12 take away 11/12, and I can't do that because 3 take away 11 is a minus number. So that's a bit annoying. So I've got a couple of choices here, and the first choice is to turn both of them into improper fractions. And this is the way that will work for every single subtraction that you want to do. I'm not sure it's the neatest way in this case, but let's have a go and we'll show you how it works. So each of these needs to turn into an improper fraction. So if I was looking at 12 as 12ths, how many would that be? 12, so 1 is 12/12. So 2 would be 24/12. So 12 wholes would be 144/12. So 12 3/12, 12/12 is 144, add the 3 would be 147/12. Okay, now 3 and 11 twelfths. So 1 whole one in twelfths is 12 twelfths. 2 as a whole number in twelfths would be 24 twelfths. So 3 as a whole number is 36 twelfths. 36 and then 11 more, 36, 46, 47. Okay, so take away 47 twelfths, and then that's a straightforward calculation to do. 147 twelfths, take away 47 twelfths is 100 twelfths. Now, I could leave it like that, or I can then simplify it. So let's have a look at this. I can certainly divide top and bottom by 2, can't I? So is 50 over 6, and I can divide top and bottom by 2 again, is 25 over 3, which then, and 25 over 3, let's have a look at what would that be as a mixed number. How 25 divided by 3, if I was going to do that, 25 divided by 3, in case you can't do it in your head, would be 8, and so 3 eighths are 24 and 1/3. Okay, so that's one way of doing it. So change your mixed numbers into improper fractions, do the subtraction, simplify your fraction, and that's the answer you get. If I go back to my original sum there, calculation there, so 12 and 3/4 take away 12 and 3/12 take away 3 and 11 twelfths. There is, I think, a slightly neater way of doing that. And it's a bit like going back to exchanging with normal numbers. So I can see that 12 and 3/12 doesn't, so the 3/12 to take away the 11/12 won't work. So if I say instead of 12 and 3/12, I'm going to say 11, and then I'm going to move one of my wholes across to the twelfths. So one whole would be, so 11 plus would be 12 twelfths plus 15 twelfths. So 12 and 3/12 is the same as 11 and 15 twelfths. Okay, and then take away 3 and 11 twelfths. And now I can do that thing where I can take away the whole numbers. So 11 take away 3 is 8. 15 twelfths take away 11 twelfths is 4 twelfths. 8 and 4 twelfths. Can I simplify that fraction at all? Yes, I can. Could divide top and bottom by 2, but it's quicker to divide top and bottom by 4. 8 and 1/3, which is the same answer as we had when we were doing it in improper fractions. So choose which way you think is best for you. As I say, I think that's a slightly more sophisticated, a slightly more thoughtful way of doing it. Whichever way works for you. If you need to go back and check on the video again, do. Otherwise, have a go at a similar sort of problem set separately.